Okay. You need to be in the leftmost flat, please. This one, right? The top left. You need to be in the top left flat. We need to talk about some key features that you will see on a graph, no matter what graph I give you. Which top? Okay. Put it so the XY coordinates, your Y should be at the top. Your Y should be at the top. So, if I tell you x-intercept, what's that mean? What you got, Gusto?
It's when you're grabbing two lines and it's where the line intersects during the x-axis.
Okay, so Gusto says if I'm looking for an x-intercept, that I'm looking for the point okay, I'm going to put point or points because it's not necessarily always going to be one. There may be more than one. So it's the points where the graph crosses the x-axis. So it is the point or points where the graph crosses the x-axis.
What if you say you cross over the right?
No. That does not mean the same thing. So I want you to take a look at your graph. There are 3 x-intercepts. Take your pencil and see if you can mark them.
What?
There should be 3 x-intercepts on your graph. Take your pencil and see if you can mark them.
So it's going to be where that graph it crosses the x-axis. So find x on your paper, and see where it crosses 3 different times. You should be able to circle that where it crosses that line, that X line 3 times. That's it. Awesome sauce.
Good.
Yeah,
you can use highlighter.
This is your paper.
Right.
What makes sense to you?
Yes.
But everybody looks like they're ready to find it. Did you find yours? Huh? You know, where did it cross? Just find your X on there. Okay, see that line going all the way across? Okay. There you go.
Okay, so when I go to my graph, where should I find my first one? Rashawn, where is it? Where do I have an x-intercept? -3. Okay, so Rashawn says at -3, 0, I have an x-intercept. Okay. Xavier, give me another one. +1. So at +1, 0, I have an x-intercept. And where am I going to find my last one, Jorge? +5. So +5, 0 is also an x-intercept. Question. I will. because I have to put another definition up there too. Okay, so we have x-intercepts. And that's where it crosses the x-axis. What about a y-intercept? What do you think a y-intercept is going to be then, Rico? If the x is where it crosses the x-axis, where am I going to find a y-intercept? Where across the y-axis. Hold on, Prashant. I know where you're going with this. Hold on a second. So this is the point or points where the graph crosses the y-axis. The point or points where the graph crosses the y-axis. See if you can find the y-intercept on your paper.
I know where it's at.
See if you can mark the y-intercept on your paper.
Yep.
Yep. You go, boy. So where's across the y at? Perfect. Where's across your y axis? Where's your y axis? And where's your graph cross? Where does your graph cross this line? Right here. This line. Where's your graph cross this line? Right there. Leave those marks because we're going to talk about this too. That's just something else. Okay. So your y-intercept should have been here at 0, 2.
Oh my God.
Wow, look.
The x-intercept and y-intercept were the same. What?
I ain't right. Let's go to the fire.
Okay. Go across to the top right. We got 2 more definitions to talk about here. The first one is a relative maximum. Relative maximum. Okay, so let's decipher this. Max. What are we talking about? What does the word max mean? More? Give me some other things. The most. The highest. The greatest. The biggest. Okay, so we're talking maximum. So this is the y value of the highest point in a particular region of the graph. The y value of the highest point in a particular region of the graph. Okay, before we jump to the graph, we have a relative maximum. We're also going to have a relative minimum. So this is also the y value of the, we're talking minimum. So we're at the lowest point in a particular region of the graph. On your graph, you should have one maximum and one minimum. Look at your graph. Don't mark anything just in case you're wrong, but look at it. You should have one max on your graph and one min. Think about it this way too. A max is like a hill, the highest part of the hill. A min is like a valley where it dips down low. So if you look at your graph, where's my hill?
Right there at the
Okay, where the 4's at. So this is your relative max. And that's positive 4. That's your relative max, and that's positive 4. Yes. You're welcome to put any extra that you need to put on. Okay. So I have a relative max at positive 4. Where do I have a relative min at? At negative 4. Okay. Okay, bottom left. We need to talk about increasing
I'm not moving.
Okay, how do I know if my graph is increasing? What's it look like?
Who does stuff like that?
Sorry, I can't hear the people that are responding because there's too many conversations going on that should not be happening. How do I know my graph is increasing? It's going what? It's going up. My graph is going uphill. I'm increasing. Okay, so your formal definition is the interval. Where the y value increases as the x value increases. So in other words, going uphill. Okay. The interval where the y value increases as the x value increases. In that same sense, increasing is going uphill, so decreasing would be going down. Okay. Going downhill. So let's get these definitions out of the way and then we'll talk about it. The interval where the y value decreases as the x value increases. Okay, so in other words, we're going downhill.
Oh.
Wow. I need to be a rapper for quiz school. So God, I'm going to quiz school.
So remember, as you go from left to right, your x value is always increasing. You always read a graph from left to right, just like you read a book. So your x value should always increase. It's your y value that goes up or it goes down.
I did this wrong.
Okay. Let's go to the graph.
Wait.
Okay. So you read a graph from left to right. So what's happening first? Am I increasing or decreasing? If I start at the leftmost point of my graph and I start going, am I increasing or decreasing? I'm going downhill from the leftmost point of my graph. It should be increasing. I'm going uphill when I start. Tell me when to stop. When do I stop going uphill? Okay, I stop here. So this entire section of my graph is increasing. Okay, that's an increase. I changed directions. And now I'm going decreasing. Tell me when to stop. Okay, so that little middle section of my graph is the decrease. Then what happens? It increases again. Okay, so my graph goes uphill to -1. From -1 to +3, it's going downhill. And from 3 to infinity, it's going uphill.
But I'm not doing that, dog.
She gets it.
I'm not doing that. I'm gonna throw it quick.
That's not
Okay,
What you say? Oh, oh, God, you can't be on me. Your mouth is shut up.
okay. The last thing we need to talk about are the many, many names that they can use to tell you they want your x-intercept. Okay, so if you see x-intercept, that is the same thing as root, as solution, as 0. Okay, so if they say, find the root of the equation, it's where it crosses the x. If they say, find the 0 of the equation, it's where it crosses the x. Okay, so these are all names that describe the x value of a graph when y equals 0. So these are all different names that describe the x value of a graph when y equals 0. When you're finished, fold your flaps into the center, and this glues in on page 23. Page 23. Once you glue that in, I need you to find this paper that says function notation and cut around the edges. Find yourself this paper and cut around the edges.
Very cool.
Oh, no, this one, right?
Mm-hmm.
What page is it?
23.
We fold it or we like?
Yeah, fold the flaps into the center, or else it's not going to fit.
Oh, well,
Does it fit sideways?
mine does.
Oh, because you've got the bigger.
Bigger than mine.
It doesn't matter. You can glue it in like that.
Right?
So you should be right now cutting this one. So it looks like this. Once you get this cut out, please go ahead and get this copied so we can talk about it. No reason for you to be all by yourself.
I had it.
There's a trash can right there for all that. Okay. Please do not let functions confuse you. All they have done is they've taken away y and replaced it with f of x. That's how you read that. F is your function name. What's in parentheses is your input. Okay, so you may see f of x. They can call it g of x. They can call it h of x. They can call it whatever they want. A of x, b of x, pick a letter. Okay. Some things that they won't call it is x of x. Okay, that's just way too confusing. Okay, the most common ones are f, g, and h. Okay, so that tells you what function am I looking at? What equation do I need to solve for? Okay, the way to evaluate. What does the word evaluate mean? Solve. Okay, evaluate is a fancy name for solve. Okay, so to solve a function, you will replace the variable with what is in parentheses. So they're going to give you something like f of 2. Your 2 then will replace the variable in your function. We're going to do lots of examples. Don't worry about that until we're ready to. Because one, you don't have anything down that I asked you to get down, and I'm not waiting for you. Another minute before I switch. Okay. Okay. It says evaluate the function f of x equals 4x minus 1. Okay. Notice what's in parentheses here. It's an x. So anything that I put inside these parentheses will replace the x in the actual function. So if you take a look, I'm replacing x with a smiley face. Okay, so when I plug it in, it's 4, and instead of x, I want a smiley face. Okay. All this is trying to show you is I'm replacing my x with whatever I put in parentheses. Okay. So this just happens to be a smiley face. Okay. Number 2. Those are some freaky looking googly eyes. Okay. Again, all that's doing is replacing x. So for googly eye, -1.
So that's all of them?
Mm-hmm. Now, once we get to 4, we can actually solve once we're actually inserting numbers. Okay. So 3 becomes 4. I can't draw a star like that, so I'm going to draw it like this. Okay. 4 star -1.
I don't know. I never knew how to draw a star.
I can only do it if it crosses. I can't do the.
Right. That's how I draw my star.
All right. So those were the super easy ones. Now I'm going to start putting in numbers. So this one I'm inserting a 3. So 4, 3 -1. So now that I actually have a value in there, I can solve. What's 4 times 3? 12. -1 is 11. There's your answer. 4. This time I'm inserting 5. Good. That becomes 20 -1, which is 19. Four and -2, -8 -1 is -9.
Miller like 19. I'm ready.
Questions? Okay. Okay. This time, they've given us 2 functions, f of x and g of x. Okay. So the left ones, we're using the left function. The right ones, I'm using the right function. So again, this tells me what to plug in. So this is 3. And instead of x, I'm replacing it with -2. So 3 times -2 is? -6 plus 2? No. -4. Good. Okay. 3 times -1 plus 2. So 3 times -1 is? -3 plus 2? -1.
That's just 0.
No, it's not. 3 times 0 plus 2.
What?
And 3 times 1 is 3 plus 2 is 5. Stop talking, please. Okay, g of x. Now they've changed it to 2 times x plus 1. Still the same concept. I'm still replacing x with the value in the parentheses. So this one is 2 times negative 2 plus 1. You said negative 4 plus 1, which is negative 3. Two times negative 1 plus 1. So negative 2 plus 1 is negative 1. Two times 0 plus 1. So 0 plus 1 gives me 1. And 2 times 1 plus 1. 2 plus 1, which is 3.
We had to graph it.
He said, do we have to graph it? Yes. How do I do that, though?
That's X and this one.
Okay, good. So the number that I plugged in is your x value. And the number that I got, negative 4. Your second point should be negative 1, negative 1, 0, comma 2, and 1, comma 5. Yes. So when you graph f of x, it should look like this. Do the same thing with the points of g of x and graph it. When you graph g of x, you should have a point at -2, -3, -1, -1, 0, 1, and 1, 3. So that line should look like that.